Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Eugenia, and I'll be your host. It's our pleasure to have Pall Corporation with us today, who will be presenting this webinar titled The Science of Whisky Filtration, Understanding Chill and Non-Chill Methods. Let me introduce our esteemed guest speaker for today, Ian Norris, Spirit Specialist, EMEA Senior Sales Engineer at Pall Corporation. Ian started with Pall in 2006 and managed the spirits market for EMEA as spirits specialist while also serving as senior sales engineer. His main focus area is whiskey in Scotland. He is based in Northeast Yorkshire in the UK. And now I'll provide some housekeeping information before we start. First of all, I would like to welcome you to our webinar platform On24. You will notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. During today's event, there will be plenty of time to ask questions to our speaker. And you can do that via the questions widget. Just type your question in this box and click submit. We will allocate some time at the end of the session to answer questions or any thoughts that you may have. You can download and review different types of resources at the bottom of your screen. In addition, we are having 4 short polling questions today, and you can vote simply by selecting the answers relevant to you. We would also like to invite you to fill out a short survey at the end of this webinar. If you require any assistance, please use the yellow help widget, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome Ian. Over to you.
Thank you, Eugenia. So for today, what the webinar is about 5 years ago, myself and a colleague from the United States presented a very similar webinar on the science of whiskey filtration, chill filtration versus non-chill filtration. So today is more of an improvement on that. We're going to cover go over some of the same subjects that we covered, but we're also going to be telling you about the advances that we've made since the last webinar that we did. We'll be looking at what the challenges are to the spirits industry. They're always there, the sources of haze and turbidity, and we're going to talk about new non-chill whiskey filtration techniques and introducing again our possibly still the best choice as far as non-chill filtration is concerned. We'll also be taking questions if you would like at the end of the webinar. If you want to ask during the webinar, please do so. We have a colleague of mine who's monitoring the questions and answers, and he will pass your questions on to me. As Eugenia said, you can also go back to this webinar once this is finished. You can also feel free to contact me at any time about anything in this webinar. First, I'd like to start off by asking just some polling questions, just so I can get a bit of an idea in my mind, is with non-chill filtration. So this is filtration, for those of you not aware, is just standard filtration with no heat exchanger involved. So you are filtering at the ambient temperature of the room that you're in. If you could just please click on one of the answers, whether you're familiar, somewhat familiar, or if you're not familiar at all. Thank you. And then I hope I've given enough time for everyone to answer there. But that's a fantastic response. It tells me exactly who it is that I'm talking to. And I appreciate that. And I appreciate your response. So just to go over the history of spirits filtration is where we are. I mean, we go back as far as 1892 when we look at DE filtration. And this was traditional for really large batches. And then about 130 years ago, we moved on to what is now known today as filter sheet filtration. These filter sheets are still in existence today. You're going to see some of the how we've moved on from filter sheets already. And then we moved on to lenticular filtration. In the Pall range, these are called the SuperDisc lenticular filters. And it uses the same media as what you would do in a filter sheet, but you can use it for both large and small scale production. I'm then going to introduce to where we are now with the 4th generation, and that is called SuperPack. SuperPack is also, it's sheet based, but it has a completely different filtration mechanism called edge flow. And that filtration, the SuperPack range, is called modular filtration. So the challenges, we're going to start with because DE filtration doesn't exist. Plate and frame filters do still exist. And what are the challenges that we're getting? And obviously, it's product loss. And if we're talking about brown spirit filtration, you're talking about a very expensive product. So every liter of spirit that is lost in this process is costing a lot of money. These filter presses, as you can see in the pictures, there's a lot of components to them. And these are high maintenance costs. These are old machinery. And also there's the labor cost that's involved in the filter changeouts, closing the filter, getting it ready, prepared for a production run. Also, there's a challenge with something like this. You're pretty much tied into large scale or you're tied into small scale, one or the two. You really struggle to do both of these. With them not being fully enclosed, you've got the ATEX concerns, you've got the vapor releases into the environment, and you've also got these units can pick up, people will be walking past, touching them, and it's got a very large footprint. So this is just a typical brown spirits that I'm talking here more or less to the people who are not very familiar with the non-chill or even the chill filtered process. So of what you've got in processing brown spirits. The first part where Pall comes into the equation is when the casks or the tankers are unloaded into what's known as the dump trough or the disgorging trough, and these are usually then the pre-filters that are used before it goes through to blending. Often we would put in a filter before, we'd recommend putting a filter before the heat exchanger, and that's just so that no particles are going into the heat exchanger. Then you would have the typical filter press, lenticular, or the SuperPack modular filters to remove the chill haze prior to bottling. You would have a guard filter as close as possible to the filling station as possible. We get haze in spirits, and what are the causes of haze? And above you can see you will have particulate haze, and this is caused really by the mechanics of processing. It can be caused by also diluting with water. So there's quite a number of, you get your particulate hazes. These can be typically quite easily removed with surface and depth filters. So surface filtration would be your pre-filters, like a filter cartridge, around about, say, 40 microns. Some people go down to 10 microns. And you would also remove particles at the disgorging trough with a stainless steel mesh, 500 to 350 micron removal rating. Then there's the colloidal haze. Now the colloidal haze this is what's a lot of from what we would say the ingredients you would have from, say, citrus fruits. There would be parts left over from the previous distilling process, and these colloids are a lot more difficult to remove. And you would use remove these colloids with typical depth filter sheet media. Now the lipids, these are what creates chill haze. Now, a typical example of what chill haze is if you have a whiskey that has a number of lipids in it. Just put a block of ice into a glass of whiskey and you will see that cloudiness form. So that is a very simple way of explaining what a lipid is. And this affects, obviously, visually the spirit, which a lot of people don't like. but it also affects the aroma of the whiskey, and that is a problem, and it will affect the taste of the whiskey as well. Where do lipids come from? As you can see, the number of places. So you'll get them right with the barley that's used. It will be during the fermentation. It will come during the distilling process, but also you're going to have the maturation process. As you can imagine, if you got a very young whiskey, you shouldn't have that many lipids in there, and it should be a lot easier to process. When you start going on to spirits which have been in the casks for a number of years, and also depending on the type of cask that's being used, a sherry cask, for example, you will get a lot of lipids from that. But also, obviously, the longer that the spirit is maturing, the more chances the lipids have growing as well. Fatty acids. So these are the typical, it's another term for the lipids. We have good and we have bad. And the good ones are the short chain fatty acids, the short chain esters. Those we want to keep in the spirit. And then you go to the long chain fatty esters, and these are what we want to try and get rid of. And now this is where the depth filter sheet media, the lenticular filters, the super pack media, the modular filtration, this is now what that is geared at. The specific type of media that you're using is to remove the long chain fatty esters and give you the optimal product. Again, here's just an example of the the character of the fatty acid esters. So you can see that the larger they are, the longer that they are, more chill haze is going to be present, more undesirable aromas are going to be present. You go down to the short chain fatty esters, you're going to have a much lower chill haze, preferably none, and you're going to have the desirable aromas that you're looking for. What affects the cloudiness in spirit as well? So again, going back to that as well, low temperature, ambient temperature, everything that's mentioned there in the picture that you see. So depth filter sheets, why are they the first choice of food and beverage applications? So surface filtration will be a typical cartridge filter where the particles, and this is used for particle removal, those will be collected on the surface of the cartridge filter. A depth filter, now we start moving on to filter sheets. And you can see in the middle there how the filter sheet is partially absorbed. These are particles which are being absorbed. And while it's good and it's got absorptive characteristics, it's not the ideal. What is the best for absorptive is super pack. We don't want super pack to be doing any particle removal. That's for the cartridge filters upstream to take out all the particles. We want super pack to only be doing absorbing and using its entire surface area. And this is how you will get a larger surface area with super pack as compared to filter sheets, and you will get a better absorptive effect. And this is used by what I will explain later as the edge flow. And the edge flow effect is just to give you an example, I've just got this piece of paper here. So if you can imagine that is a filter sheet, just a typical filter sheet, and your flow is through this. That's there, the edge, that there of a filter sheet will be the size of your surface area. Now, if you have turned this filter sheet on its side, which is what we've done with Super Pack, and the flow is still that way. Now, as opposed to that being your surface area, that is now the larger surface area there. That is just edge flow explained very, very simply. And you could be able to understand there why it has much better absorptive effects. Chill filtration. So people who are very familiar and familiar with the spirit processing, you will know and you'll recognize a heat exchanger immediately in the picture. Typically, the chill filter, the temperature is set at, say, between 2 to 4 degrees, minus 2 to 2 degrees Celsius. That's Celsius. I have myself come across a heat exchanger that was set at minus 10 degrees Celsius. And so you can imagine these reduced temperatures, they cause the lipids to become less soluble. So they're harder to get rid of. So you use the filter sheet media, and you now need to absorb these. So you can just imagine the way I've explained the super pack with its edge flow and the greater surface area, you'll be able to absorb a lot more lipids by using the edge flow principle and the modular super pack filters. Non-chill filtration, it's been around for, I guess, as long as what chill filtration has. But over the past number of years, we've seen a boom in non-chill filtration. And the drivers from the conversations that I've had amongst the industry is really, it's a marketing point of view. The whiskey producers are trying to get as an original taste as possible, original flavor and aroma as possible to what is in the cask. By doing the non-chill filter process, you are able to get that. You're removing less, you're stripping less color, you're stripping less aromas, you're stripping less flavor. How do you do it? You just simply remove the heat exchanger. That's the easy way of me saying it, but that is what it is. So what drives it? From my own, what I've seen and speaking to a number of colleagues, we see a lot of the smaller distilleries when they're starting out going towards the non-chill method. That could be for a number of reasons. A, they've chosen to go that route from a marketing perspective because they can brand the bottle non-chill filtration, non-chill filtered, so that the consumer then will know that they are getting a product that's as close to the cask as possible. It could be for capital expenditure. Like I said, it's a very expensive component. With spirits filtration, whiskey filtration, specifically, the main driver for ambient temperature is quality. Is the analysis at the end is the actual quality results that you're going to get. The driver there would be your colors, aromas, flavor, turbidity. And with non-chill filtration, as you'll see later, so with a normal chill filter, so if we have a chill filter set at 4 degrees Celsius, you will get a throughput of about 25,000 liters per module in throughput, all things spirit dependent, depending on what type of whiskey it is, what type of brown spirit it is. With non-chill filtration, you're seeing a throughput of around 40,000 liters throughput. So if you indulge me one more time, please. I'm saying, yeah, with your customers here, that's actually more of a question for me. But to yourself, I will leave out the with your customers part. But do you see the trends towards non-filtration in the whiskey industry? Do you see an increasing demand? Do you see it staying the same as what it currently is? Or do you see the decline in non-chill filters? Are you seeing that demand declining? If you could please just click on the screen, I'd greatly appreciate it. So I'm giving 20 seconds for each one of these. Okay, so it's it's kind of what I thought of from my own perspective. I would have expected to see the increasing demand a bit higher. It's good to see, again, I thought that the stability would be round about that. But thank you so much for answering that. It's greatly appreciated. So this is a filtered whiskey example. It's just an example of a site of mine that I took as an example, that their target is a turbidity of no more than 2 NTU. They're currently using Detsfield sheets. I just wanted to give people who are not familiar what a whiskey process looks like. So from the barrel to the dump trough, this particular site has a 500 micron mesh. They use bag filters before they're going down to the heat exchanger and the whiskey holding vat. That's to try and remove as many particles as possible. And then it goes through the chill filter. This one is a 0 to 4 degrees centigrade it's set at. And they're using the Pall 600 by 612 millimeter sheets. And then they go down to a guard filter, which is cartridge filters, just prior to bottling. So I just wanted to show people that just an example of a site. And then just looking at the results here, we've got the turbidity readings that we take. So when we do these trials, or we do anything like that, we always try and get the readings of what so a tank, this is a tanker offloading, or the tank after the barrels have been disgorged. We try and get a reading on what the turbidity is, because we know that we're targeting no more than 2 NTU. And then we've got, after the water's added, and then we look at what's the bottling vat sample is. That's what will be going into the bottle. And so with the process of the picture that you've just previously seen, these were the turbidity readings that were taken. And again, sorry, I think this is the last one. One thing that I'd like to know from you all is, do you often receive claims from your customers about the turbidities of the bottles that they've purchased? I'm seeing, chill haze in the bottle, or haze forming particles in the bottle. Do you often get that? And is it a concern as well? That you obviously don't want to do that. If you could just take 20 seconds to answer for me there, please. Thank you. Yep. Thank you so much. I really do appreciate that feedback. So non-chill filtered, and again, I've taken a site, and so now this is, if you can think back now to the filter press. So now we're onto non-chill filtered whiskey with the Super Pack modules, and for the first time, the Super Pack housing makes its appearance. So as you can see, the maturation and the dump trough is the same. This is just a site that's gone and used a stainless steel 50 micron. And they've gone down to 4 micron cartridges and 2 micron cartridges. If you can imagine, this is non-chill filtered. So this specific line is low volume, very high value product. So they want to try and extend the life of the Super Pack as much as possible. And so, which is why they've actually gone down to a 2 micron cartridge prior to the Super Pack filters. You'll see there's no heat exchanger here. And this particular line has 3 Super Pack modules. And it then goes down again to the normal 10 micron guard filter prior to bottling. Again, this one, a typical target of 2 NTU, really is one of the more common ones that we see out there. And then you can see the difference. So the tanker turbidity after the water, after adding the water, and then you can just look at that bottling sample that we got there, and we were given a not to exceed 2 NTU, and I don't even think that we exceeded 1 NTU. So we felt very safe after doing this. And this particular site, when they compared their chill and non-chill, actually told me that these were the best quality analysis results that they'd ever received. Happy to say this was a few years ago, 2 or 3 years ago, and they still keep that process in place, and they're still getting the exact same results. What I spoke about earlier, so chill versus non-chill. So now we're talking specifically Super Pack. So again, this is a site where the 2 NTU determines the change out. So as soon as you reach that target, you change out to the Super Pack modules. And again, I believe this was set at no more than 4 degrees Celsius when they did the chill filter. The 6 modules that were in place managed to do 40,000 liters each. As I said earlier, that's above average, even for a filter that's being chilled. That's good throughput, but it's also they've got extremely good pre-filtration. And you could see that they did 240,000 liters. I think that they were running at round about 15,000 liters per hour when they did this 240,000 liters. They then did another batch of non-chill, and there actually was a number of batches. So, and they ran these two side by side, and they also used 6 modules. They were getting 83,000 liters per module through using non-chill filtration. Memory serves me correctly, it would have been round about between 12 and 15 degrees ambient temperature, maybe lower. It could have, on the time of the day and how long it took. So, but I think the maximum that the temperature hit that day was no more than 15 degrees. But their entire, before we had to change out the filters, as they'd reached that turbidity of 2 level, we'd managed to do a total throughput of 498,000 liters. So what are the conditions? Well, we say it's that the Super Pack, the most effective, is older than 2 years. It's the ethanol content. We need to adjust it to about 43%. We do find it anything a bit higher. We don't always fail, but we're very secure when we're at 43%. Ambient temperature is below 20 degrees centigrade. When we first started doing the trials with non-chill filtration and Super Pack, we actually picked summer in Scotland, and while some of that might bring a smile to some of your faces, this was a hot summer when we did the very first one, and we had average temperatures of 24 degrees centigrade that we were doing it in. So we tried to pick the worst conditions that we could do it in. We still do that to this day with Super. If we're doing non-chill filtration, it's easy to do it in winter in most parts of the world. So if you can be successful in the summer, you then can be confident going forward that you'll be able to do it in the winter. The Super Pack module that we try and do, we try and keep it with spirits at 3,500 liters per module. So you get 2 modules, you can move up to 7,000 liters. It all depends on your batch. And we also as well, with all filtration, but mainly with non-chill filtration and Super Pack filtration, we really try and get the best pre-filtration as possible. We're trying to have no barrel char particles or any other particles hitting the surface of what is an absorbative material. So here is a Super Pack module. As you can see, it is made up of filter sheet material. So we're still manufacturing the same type of filter sheets that we've been doing for 182 years. We still do manufacture them. But with SuperPak, we just do something different with them. We wrap them around a polypropylene inner core after they've been punched through with these holes. Now, these holes are what creates the edge flow technology, because not the filter, the spirit, sorry, does not just travel in a straight line through to that plastic inner core that you can see, but it actually goes around the filter until it reaches the plastic inner core, because these holes do not line up directly, as I'm about to show you. So there you can see how the holes have been punched on the outside, and then you can see as they go through the middle, there's the more numerical ones, and then down to the bottom. And then you can see how it then goes on to the very lowest part. So the filter will the spirits will quite easily proceed through the first couple of layers. And then it hits those other layers where it then absorbs into that material, but it does so by going around until the spirit gets to the polypropylene inner core, which is then goes to the outlet. So that is how a filter sheet, if again, I'm just going to use why I didn't, a filter sheet, you'll probably have it, that will be your effective filter area, where I'm circling my finger there. And this outside here will not be used at all. So a lot of wasted filter area. With the SuperPak module, you're using every single part of the module of the surface area. You're also getting a much larger surface area, and you're able to then, at the end of this, it's so much stronger that you can blow through with gas, air, to try and get as much of the spirit out of the SuperPak module, so you're having no spirit loss. So no drip loss, no lower hold-up volumes as well. Again, that's just an example of, if you're still trying to work out how the SuperPak works, it's filter sheet media. It's been punched through with holes, and as you can see, these holes do not line up. So it travels through the first layers of the SuperPak media and then starts spreading around the module using every single part of the surface area. This is just an example here. It's just trying to give a very easy drawing. So you can see the holes there on the left-hand side, and then just the drawing on the right. So you can see it travels through, and then all of a sudden there is not a traveling hole for it to go through. So it takes a turn to the left or to the right or up or down until it can find another traveling hole to proceed through to the inner core. And again, while I was simplistically trying with my piece of paper to show you the different standard flow rates and how much surface area is moved, you can see the red line. If you could imagine, that's a typical filter sheet just moving through, and the tiny surface area that it's using, as opposed to the SuperPak, which is moving all around the module. Different sizes of SuperPak. So we have L, M, and S. These are secret codes for large, medium, and small. As you can see, they're all the same height, and the large, medium, and small modules will all fit into the L series housing. Now there's the L series housing on the left-hand side. You can see all the full accessories. This is a 4-high housing. So you have the riser pipe on the left-hand side. So you'll have the flow coming in from the top and the flow coming in from the bottom. You've got ventilation valves with sight glasses. So you can see that all the oxygen has been removed from the housing, so that you can be rest assured that you are using every single part of the surface area. As I said before, you can see the heights of the M and the S, just the different widths. So if you are using a 4-high, you have like about a 75,000 liter batch of spirit that you need to filter, either chilled or unchilled. You would use your 4-high L series housings. But then what happens if you come along and you've got 1,000 liters to do? Do you go and buy a new small SuperPak S housing? Yes, you can, if you want it on a different line. But if you have spare production capacity, or you're not producing the 70,000 liter batch that particular day. You could take the S series housing and you just reduce that L series to a one-eye housing. You can see the split domes. Those inner domes can be removed and the top dome can be put onto the bottom, and you then have a one-high housing where you can do 1,000 liters of spirit through an S series module. So you're not going to have any excessive stripping because you've got excessive surface area. The same as if you've got, say, about 2,000, 3,000 of high value, low volume product to do. You can put the M series in. It doesn't necessitate you having to buy multiple housings to do multiple size batches. A lot of people do like to have a dedicated high value, low volume line. That is where the S series comes into its own, especially in the non-chill filtered. I'm talking people who are doing 30-year-old whiskies with absolute confidence, just using a good pre-filter. As I've said before, a 30-year-old coming out of a cask is going to pick up a lot of barrel char, and we want to try and use as much of the surface area of that little module as possible. And that will the S series will do 1,000 liters quite easily. The grades which are normally in use. So if you can see there, the super pack range, there is a number of grades. Normally it is the 5.7 and the 5.9. In general, the 5.9 is the most commonly used with its characteristics. And for difficult spirits that have high starting turbidities, so if you think of sherry cask whiskies, you would then possibly need to, if the 5.9 is not going to do it, you'd need to move to a 5.7. There are sites that do two-stage filtration, especially if we're up in the very high volumes, that would use a 5.9 in the housing and then another housing downstream with a 5.7 involved. Again, this is for the very difficult, with the very high starting turbidities spirits that are being processed. So that's a two-step filtration. And this is the last question from me. In your process, whether you have filter sheets or lenticular or the super pack, how high do you rank flexibility? So being able to move, say, on one line from high volume to be able to do a low volume on the same line. How the flexibility is. So if you had something like a super pack housing where you could do it on one line and go from a 4 high, and then tomorrow you've got low volume, high value products to produce, how important would it be for you to move to have that flexibility? Wow, thank you so much for that. It is a response that I was I would say the word is hoping for, but thank you so much. That's a really excellent response. I greatly appreciate that. To the best of my knowledge, that is the last questions I'm going to be asking. So, why super pack technology? I'm not going to read everything that's on the screen. As I said, you are able to go back to this presentation. There will be information on there. You can contact me or any of my colleagues around the globe. Is why is super pack technology the best choice? The picture that you've got there is actually a super pack housing that is from a show. It's not what one actually looks like in real life. It's just so that people coming to the shows, it's a demo model, can see inside the housing the different size modules, the L, M, and the S that are being used. They can see how the flexibility of the housing. And just briefly, as I say, I'm not going to go through anything. You will have uh, very low hold-up volumes if you blow through with it. None of that affect to the environment. The ATEX, these are fully ATEX certified in a closed environment. You've got no drip losses. So, but as I say, I'm not going to go read through all of that. You're more than welcome to come back to it, or even contact someone, myself or someone within Pall, to get the answers for this, or to get this information. Now, the last time that I did this presentation a number of years ago, SuperPack had reached its sort of its peak in terms of its technical features. Since then, we have had introduced a new type of media. This is ZD media, or as my American colleagues like to keep pointing out to me, ZD media. What this is, it's a pure cellulose media. There's no diatomaceous earth. And what this is giving us, so you've got the same SuperPack module, but just with a different grade of sheet. So I showed you the different grades that we had before. And now this is now the ZD media sheet. And it has far less impact on color and flavor stripping. There's reduced water consumption. It's easier to dispose of, and you're getting a much longer service life out of this. So this is the new module that's come in, and we're seeing it especially with things like if someone is doing non-chill filtration. Well, now we're going to, with this media, we're getting even less stripping of color and aromas. This is just again a typical Whisky flowchart where Pall enters the situation from the barrel char removal and then down right all the way to the bottling. And you can see there, that is the SuperPack module. That is where it's in place in the filtration process. We've got particle removal. That there, I want cartridge filters. I do not want these particles to get onto the SuperPack media. The particles will block the outside of the SuperPack, and it will then give a shorter service life. So just to give you basically an example of what an L module, just a typical L series module. So it has a surface area, as I explained to you about how we use the entire surface area of the SuperPack module of 8 square meters. If you know the 60 by 60 sheet, that's going to be 24 60 by 60 sheets or 56 40 by 40 sheets. And as I explained as well, we don't use the entire surface area of those filter sheets. This is an example, and it's actually an example of one of my my customers' distilleries. So this was a few years ago. They had a plate and frame filter in place, 76 600 by 612 sheets. They were having to do double production runs of 8 hours a day, okay, to try and produce this batch. The reason they were doing that is that the turbidity reduction was not meeting specification. So they had to do double filtration. So that took 2 days for them to do this batch. You've got a timeout, and then there's 104 batches a year. So your production time is going up. So we were approached, and they wanted us to help them out with their most problematic batches, the batches that they were having to double filter. They wanted drip losses and hold up volumes removed. And they had these existing filter presses. So for us to bring in new equipment, they were very restricted with space. Fortunately, SuperPack takes up very, very little surface area when you compare it to a filter press. because of the size of the batches, we used a 3 high, and in the first production run, we did 8 hours, and we were within the turbidity specification, the color specification, the flavor specification. We met all of the criteria. We then blew through for 15 minutes afterwards to get all of as much as we can of the whiskey out of the housing so that this was going through to bottling. And there are the benefits to the customer. That we'd reduced their production time by half, and they were getting a better throughput with no drip losses, no hold up, and we'd reduced their operating costs as well. I'm going to leave you now with just this last one. So I spoke about 2-step filtration. So if you go to the left, you've got your barrel, your disgorging barrel, and then you go down to your cartridge filters before a heat exchanger. And these were the 2 3 high super packs that were in play at the time. And then you would have a 10 micron filter cartridge prior to the bottling line. Again, if you wanted to do a non-chill filtration process with these, you don't have to change the modules, the grade of the modules. All you have to do is either switch off or remove the heat exchanger. That's all from me. I really appreciate everyone's participation and in answering the questions that I put through. I seriously appreciate you taking the time to listen to me today. Thank you very much. If there's any questions, I'd love to answer them.
And thank you very much for this presentation. Just a reminder to the audience, to ask questions, you can send them via the questions widget. Just type them in this box and click submit. Please note that you can still send your questions after the webinar and they will be answered at a later date. And it looks like we've got several questions already. And here's our first one. How bad are very low temps of whiskey quality?
Very low temperature. I think that person is referring to the one I had at -10. But it was filtered. It passed all of the. It went through SuperPack module. It passed. I think the turbidity target was also 2 NTU. They had their different levels of flavor and aroma. But it was, yeah, it was fine. It caused us and them more problems for them to get the results that they wanted. It just caused, obviously, using a heat exchanger a lot more for a lot longer, I think. But it caused us a bit of a headache as well in trying to find the right media. But we did, and you know, since then, we have no comeback. It worked, and it's still working very well.
Thank you very much for that response. And we have another question from the audience. At what temperature should turbidity be checked before bottling? Ambient, lower?
It's as far as I'm aware, it's always checked at ambient temperature. You know, that's when you're going to be consuming the product, so it will be at ambient temperature.
Yeah, thank you very much. And here's our next question. Can you say more about higher ethanol concentrations affecting the process? Some products must be held at higher concentrations than 43%. Apologies, we. I'm not sure what it is. Sorry.
Yeah, it's the higher ethanol contents are more. They fall into that category of what is more difficult to filter to achieve the correct results. When it comes to non-chill filtration, like I said, we had. Well, like I did say, we have had some success with the ones at the higher ethanol content. There's some that we haven't been able to do with non-chill filtration. But with the 43% ones, everyone is we've been successful with. There is always ones out there that are just going to be causing problems, and there are solutions to it, but it just involves a lot more filtration, a lot more from the production side as well. And yeah, so there is always solutions, but it becomes in the time that it takes to be able to do this. Does it make it worthwhile?
Thank you very much. And we have another question from the audience. Thanks, Ian. Is the flow rate of 3,500 liters per hour based on filters in series or parallel?
No, the filters are in series. You know, so if they're you can have a 1 high, and so you say you have the 2 stop where you have the 5,900 going on to the 5,700, then that would be in series there. That is still the module is that speed. When you put them in parallel, it's still that is the maximum speed per module. So whether it's series or parallel, that is still the maximum speed.
Yeah, thank you very much. And here's our next question. 43% is the low alcohol threshold, correct? Is there a high limit on alcohol concentration?
I think it's specific to the country where you are. I don't. I think again, it's if we say whiskey, but I think it's country related where you are. I've just had a very recent experience where I purchased while on holiday a same spirit, but in a different country with a much higher volume content, alcohol content, and I didn't think it was manufactured like that. But so even I still learn, you know. But yeah, I think it's in the country where it's sold. Certain countries have their limits, and some obviously aren't as strict. I think that's the answer that I'm looking for. Yeah.
Yeah, thank you very much for that response. And here is our next question. Can this be used for other malt beverages?
Yes. So when we first started this, as I said, it was myself and a colleague in the United States, and I was working on whiskey with non-chill filtration, and he was working on rye. And while there are the similarities, we then moved on. Both of us moved on to a brandy. We've moved on to grain whiskies. So there is in brown spirits, yes, it is across the board. Our knowledge was first introduced with things like whiskey and rye.
Yeah, thank you very much. And here is our next question. Is it necessary to have a water pre-run at the super pack before starting to send the spirit?
My advice, please do not allow water anywhere near those super pack modules. You're going to, there will be some it's an absorbative product. It's the same with filter sheets, lenticulars. They absorb, and there will be some water retained in those modules, and you're going to spoil your product by doing that. You're going to have haze formed for a start, but you're going to definitely going to affect your flavor, and you're definitely going to affect the aroma. So what we do, if it's a brand new module, what we recommend is to do a recirculation. This has a number of effects. It colors the module if it's brand new, and it also it as well. It's so you're getting the color in, and it's rinsing it as well. So if there's anything sitting on the outside of the module, those will then be captured before you're going through to the filter, so before you're going downstream. So yes, absolutely do not introduce water. That's possibly the biggest no-no. And just if you want to, if you have to recirculate, do so by using the whiskey that's being produced. You're not going to lose any spirit. This is a closed system, and it's just so recirculate, get your color, get strip off whatever it needs to be stripped off the module, and proceed straight through. With a used module, this is not a problem. So you can use a used module again. You've already it's been inside a closed housing. So, but just again, one last time, please, no water at all.
Yeah, thank you very much for that response. And here is our next question. What is the purpose of the 10 filter after the super pack?
Okay, so when you go from the super pack, it's going to go to a bottling vat. I would say 99% of the time. It's going to sit in the bottling vat until the plant is ready to bottle. Now, not all sites have their own bottling lines. So the bottling vat will be there and taken, pumped into a tanker that will go then to a bottling hall, a central bottling hall where everything is bottled. So you can imagine this vat, and especially with the restrictions that we have on people, getting these vats clean, and the different types of spirit and the different types of whiskey that's going into these vats. There's also the human element as well, of having the vats inspected, of opening the vats, of whatever. There's something that particles or something that we don't want in the spirit can get in there. I'm not saying it does, it can. Then whether you are then moving from the bottling vat to a bottling line, if you've got that set up, you need that 10 micron guard filter as close as possible to the fillers. So if there is any particles picked up in the line from the vat or either in the pipework to the bottling line, no unwanted particles are going to get into the bottles and are going to appear on the shelves when of your customers. Then also there's the ones that go and think of when the tankers, so the tankers are being filled or RBC containers are being filled. They then go to the bottling halls and it needs guard filtration again for the same reasons, that there is a higher chance of unwanted particles being picked up. I don't know what a wanted particle is, but particles being picked up and appearing in the bottle on your customer's shelves.
Thank you very much. And we still have time for one more question today. And here is our question. What have you used to empty the filters, if not water, air?
When you blow through the filters, again, I'm going to stress, please don't use water. You don't want that ending up in your final product. The optimum use of gas is nitrogen. We understand not everybody has nitrogen, so CO2, air, the normal standard types of gases that you have on a site, and that's what you will blow through with. And you don't blow through at a very high volume. 1 bar or something like that is possibly the maximum that you need to blow through the modules. So it's a very low pressure setting. So you're not going high as what you would be, say, when you're doing the actual the flow rate. So it's a very low setting, about 1 bar maximum to blow through with gas to get all of the spirit that's being held up.
Yeah, thank you very much for that response. I can see that we still have a couple of minutes and we can answer one more question. So here is the question. Does the non-chill filtration works only for whiskey or also for another kind of spirits such as rum, gin, vodka, etc.?
I've never seen with vodka, to be honest with you. I have seen with brandy and cognac. I have seen with rum as well, and as I mentioned, rye. So yes, in dark spirits, yes, it's pretty much used across the board. Things like vodka, it could be. I've never come across it. I don't know why you would with vodka, unless it's the flavored vodkas that are being produced. Maybe I've never come across it, but I don't see why it can't be done. And it might be something worth looking into in the future.
Perfect. Thank you very much. And just a reminder that you can still send any questions while watching on demand. All questions will be answered at a later date. I would like to thank Ian for this presentation and Pall Corporation for sponsoring this session. To the attendees, you will receive an email telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is pmi-live.com. We look forward to sharing further webinars with you, so please do keep an eye on the website just mentioned. Thank you once again, and I hope you all have a nice day.
Thank you.